So this class is an easy A, right?
Oh,
Right. I wish.
yeah.
That's supposed to be 215.
Oh,
So is it supposed to be 215 now?
Yeah, I think
it's only a 15-minute class.
2:15. Cool.
That's what I thought.
2:15. 1 hour class, the bit of a class.
Is this the whole class?
We are like, we should be 7 of us, actually.
That final was tough, wasn't it?
Which one?
Tough.
Yeah, that was like the hardest bit of them all.
Well,
I think I got like a 60. Which I'm kind of.
So you guys know one another?
Yeah, we were in the same class.
So I just met you guys.
Oh, okay.
I'm new.
Yep.
We're
So-
friends already though.
Yeah, we're good people. I like it.
Okay.
We showed up early and got to know each other.
So I will be recording this.
Awesome. Thank you. It's great on the curve though too. Like, so without the fourth curve, I don't want to know what I got. But with the curve, I did good.
I don't know whether people will be seeing this one in Zoom. I'm trying to connect this. Let me look for the.
So this one.
Yeah. One. Which I'm glad I didn't sign up for more because it was like $3,600 to take 3 classes. I found out that my student financing loans and Pell Grant had already been maxed out, so they didn't give me anything.
They didn't do any programs?
So I got a balance now. That's good. They'll let me pay me. I gotta take this class.
Yeah. Otherwise we'd be stuck. It would have like a whole year. Graduation day, because you have to wait. You don't take the class in the fall. You have to wait till next fall.
really screwed up because some of the classes are like only on the odd spring and only on the even springs. It's like,
Are you seeing this? Is it clear?
Yep. Most part. Except for my head moving.
You're good.
No one is in the office, but I will send the notes in Moodle if in case you need them. Okay, so let's go through this. Okay, so this is actually 2:15. So it's to 1 hour 15 minutes. So it's not 15 minutes. Okay. So that is my name. Call me Kip. I was here with this guy last summer. Yeah, so this is linear algebra. So it's a 200 level course. So it's a 200 level course. So if there are some prerequisites, so at least should have done 1170, which one? College algebra or
Calc 1.
calculus 1? Oh, okay. Should have done calculus 1. Okay, so it is a very wide course actually. It's very wide. So we will try do up to like chapter 5. If we reach like 5.3, then it will be good. But it's very wide. So it's actually from chapter 1 to chapter 5. If in case we get time, then we might do chapter 6. But basically, I know we will reach like 5.1, 5.3 there. And 5.3 is just dealing with the eigenvalues and the eigenvectors. Okay, so in this class, every point matters. So I'll not be doing the percentage. So I'll just be taking the points. So exam 1 will be 100 points. Exam 2 will be 100. Exam 3 will be 100. Final exam will also be 100. And then, so we have the homework, which is the average or the overall will be like 50 points. And then we have a worksheet. Worksheet we'll be doing it, we'll do 5 of them. So each worksheet is like 10 points. So it's like we will do it every Thursday in class. So we just do it in class. So try to be in class, but I will announce it on Wednesday. And then I'll tell you the part which I will set in the worksheet. Okay, so it will be worth 50 points. So 10 points for the 5 of them. Okay, so the total points are 500. So every point matters. So it's not like a percentage. So the percentage can be easier because you can just do the average of things, right? And you can still get a higher percentage. So this one is it's a little bit better than the percentage. Okay. The first homework will be due this Friday. Because the first homework will be due this Friday. And no late homeworks. So if you get a late homework, then I might deduct 10%. So try. So if you just let me know if you have any issues, then I will of course I'll accommodate that. But try to finish them before Friday 2 p.m. So you just scan it. I'll create homework section in Moodle, and then you just send it there before Friday, 2 p.m. 2 p.m. So you just scan it and then you send it. So the textbook is this one. And make sure you check the edition. So it's the 6th edition. So the textbook we'll be using for our homeworks. So I'll not give you any, apart from the homeworks and the worksheet, there's nothing else that I will give you in class to work on. So it's just the homeworks, worksheet, and the exams. So nothing else. Yeah, so make sure you check the edition, because some of the editions, the numbering of the homeworks might be different. So they might be different. Okay, so before each exam, then we'll do a review. So we'll do a review. So actually the first exam is on 6th, on 1st of next month. The second exam, and this will be actually be on Wednesday. So you do it on Wednesday. So by Thursday, I should be giving back your exams. So you do it on Wednesday, the Thursday, your results. So the second one is like that, and then the final, make sure you remember the dates. The final is the last day of our class, which is on Thursday. So the last day. Okay, so I'll be recording the class. If in case I don't record the class like today, then I will actually post the notes in Moodle, so you can still print them. So try not to miss the class. You can come to class. So if Moodle is not working well, then it can be difficult to work on Moodle. I mean the Zoom. So try to come to class. The first exam can be a little bit easier. The second one, third one, and the final exam might be a little bit harder because it will be a little bit comprehensive. And then each section is actually related. So from the first section to the last one, so it is related also. So what we do in the first section, apply everywhere you go until the last section. So it's an exciting class, so don't be worried. This is not very hard. Actually, it's not that hard because it's direct. It's not like calculus or anything else. This one is just most of the things here will just be dealing with the matrices. So just adding, subtracting, getting the inverse, and all the stuff. Yeah. So it's actually very direct. Okay, so I will be in Maths Center every day, Monday to Thursday, from 10 to 12. So I'll just be there. So if you come, you'll just find me there. Yeah. So if you have any questions, you can actually find me there every day, Monday to Thursday. Or you can email me anytime. So if you need any clarification, any issues, then you can let me know. Okay, any question? So the homework first homework will be due this Friday. I'm sure you remember that. Okay. Any question up to there? Okay, so this is the grading system. So if you get like 465 to 500, that is A. 450 to 464, A minus. So as I said, each point matters. So try as much as you can to get the highest points as you can. So also during your exams, make sure you at least write something. If you don't remember anything, then try to write something. You can get some partial credits. Okay, any other questions?
If for some reason we know we're going to miss an exam, can we schedule to take it in advance with you?
Most of the time, it's always hard to set another exam. So if like we can agree on when each one of you will be available to do the exam. Yeah, it's not something difficult. So I just want you guys to do the same exam, all of you. So if you can agree, all of us in class, the day you guys, but it should be within the week of the exam.
Because like I already know that I'm probably not going to be here the
22nd
Yeah.
of June.
Which you have as exam 2.
Yeah,
So
we-
I'm gonna miss that Wednesday and Thursday.
So we will like,
First it is.
before then we'll have
I
known what we.
hate to make everybody.
So that's something easy. So we'll figure it out when you guys are ready to do the exam. Okay. All right. So any other question? So if you have any issues, you can always talk to the chair of the department. Okay. Before you talk to the chair of the department, of course, you can talk to me first. Right. Any other question away from class or anything that you guys didn't have any issues with? So we will try to write a couple of notes. So the notes actually will be good. So you just study the notes then. So try write some notes. Okay, so let's start from section, so which is chapter 1. And we'll start from 1.1. And this is systems of linear equations. Systems of linear equations. Okay, so the first section that we'll do is the system of linear equations and the solutions. So the first one is we'll try and define definition. So what is a system of linear equation? A system of linear equation. Or we can call it linear system. So we can actually call it linear system. Linear system. So this is so a system of linear equation or a linear system in n variables. In n variables, and these variables are like x1, x2, x3 until xn. These variables are x1, x2, x3 until xn. Is a collection of finitely many equations of the form a11 x1 plus a12 x2 plus a1n xn equals to b1. The other question is a21 x1 plus a22 x2 plus a2n xn equals to b2. So you can continue like that up to am1 x1 plus am2 x2 plus amn xn equals to bm equals to bm. So these are a collection of finitely many equations. So these equations are m. So actually have m equations here. So m equations. So we count them in accordance to the row. So these are m equations. So where aij, where this I is equals to 1 to all the way to m, and j is equals to 1 to all the way to n, aij, where j equals to 1, I equals to 1 to m. So this is I, so going down here. So these are I, and then j are the ones which are going down like those. So we'll see this a, I, j. So I will be our, I will be our row, and our j will be the column. Okay, so where aij are given numbers called, so we call this one the coefficients, and bi, where I equals to 1 to all the way to m, are given numbers called the constant terms. So those are the constant terms. Now, a solution of the above a linear system is a list of numbers S1, S2, all the way to Sn, such that all equations in the linear system hold when x1 equals S1, x2 equals S2, all the way to xn equals to Sn. So we can solve this linear equation to get the solutions here, which are now x1 to be S1, x2 to be S2. So if you did algebra, so we can have two equations, linear equations, which are like quadratic or simultaneous equations. So you can have two. So you can solve the two equations by getting the values x1 and x2, something like that. So in our case here, we'll have we'll do two ways of solving this. So one of them is by using what you did in algebra, which is You can use the elimination method, you can use the substitution method, or you can also use, in our case here, we can use the matrices to get a solution of that linear equation. So actually, at the end of it, we'll see how we can check these ones, the coefficients here, to be the entries in our matrix. And these coefficients here will form the coefficient matrix. So we'll see about that. So don't worry about it. Okay, now let's look at the first example here, how we can get the solution of an equation. So example number 1. Show that x1 equals to 2, x2 equals to -1, x3 equals to 1 is a solution of the following linear system. So we have x2 plus x3 equals to 0, x1 minus x minus 3x2 equals to 5, and then minus x1 plus x2 plus 5x3 equals to 2. So show that x1 is a solution of that. So how can we show this? So we just substitute the values of x1, x2 in our linear system there. So the solution. So when x1 equals 2, x2 equals to -1, and x3 equals to 1, then our x2 plus x3 equals to 0, x1 minus 3x2 equals to 5, and minus x1 plus x2 plus 5x3 equals to 2 are now equals to. So our x2 here is -1, so -1 plus our x3 is 1, and what we get here is 0. Also, this our x1 is 2, and then minus our x2 is -1, so 3 minus 1, and this should be equals to 2 plus 3, which is equals to 5. And then minus x1 is 2 plus x2 is -1 plus 5 x3 is 1. And this will give us -2 minus 1 plus 5, which should be equals to 2. So therefore, then x1 equals to 2, x2 equals to -1, and x3 equals to 1 is the solution sets of the linear system. So that is a solution set of our system. That's a solution set. Now, let's look at another definition here, 1.2, which is equivalent linear system. So what is an equivalent linear system? So if two linear systems are said to be equivalent, if these two linear systems have the same solution sets. So if you have the same solution sets, then the two linear systems are equivalent. The two linear systems are equivalent. Okay, let's look at another example here. Example number 2. Find all solutions of the following. A linear system and sketch the graph of the equations in the linear system. So our equation here is 2x1 plus 4x2 equals to 1, x1 minus 3x2 equals to 3. So this, how can we find the solution here? So this is actually simple. If you can use like 2 ways here. So what you can do here, you can use the what? Elimination method, or you can use the what? Substitution method, right? So if we use the elimination method, so if we have this system here, 2x1 plus 4x2 equals to 1, x1 minus 3x2 equals to 3. So let's use elimination method. So let's use elimination. So how can we use the elimination method? So what you can do here, we can eliminate x1 there, right? So to eliminate x1, then we can multiply that by 1 and we multiply this by 2, and then we do what? And then we subtract, right? So when we multiply that by 1, it is still the same, x1 plus 4x2 equals to 1. And then when we multiply this by 2, 2x1 minus 6x2 equals to 6. And then we do what? We subtract. So when we subtract 2x1 and 2x1 here will give us 0. 4x2 minus 6x2 will give us what? 10x2 equals to 1 minus 6 is minus 5. And when you divide both sides by 10, then x2 will be equals to -5 over 10, which is equals to -1 over 2. 1 over 2. Then we now take this x2 here, not this, so we take it here. So we can use this x2 in any equation here. So we can use it on the second one. So to get x1 minus 3, our x2 here is -1 over 2 equals to 3. So x1 equals to, so x1 plus 3 over 2 equals to 3. Then we take this one to the other side. So x1 equals to 3 minus 3 over 2, which will give us 6 minus 3, which will give us what? 3 over 2. So our x1 equals to 3 all over 2. x1 equals to 3 over 2. Okay. So that is it. Right. So that is our solution. So another way is, now you can graph it, yeah? So you can graph this system to get a solution. So when you graph it, that is where they meet, the point where they meet is the solution of that system. So to graph this one, then if you use the graph method, then if you have 2x1 plus 4x2 equals to 1, x1 minus 3x2 equals to 3. Yeah. So starting from the first one, if you take 2x1 plus 4x2 equals to 1 and x1 minus 3x2 equals to 3. So you can so if you let, in this case, if you let x, let's say x2 to be equals to 0, x2 to be equals to 0, then our x1 here will be equals to what? 1 over 2, right? So our coordinate here will be 1/2 and 0. If we let x1 to be equals to 0, then our x2 will be equals to 1/4. So our next coordinate is 0 and 1/4. 0 and 1/4. So you can plot that one. So you have 2 points already. So 1/2 and 0 and then 0 and 1/4. So you can draw, since this one is a linear system, then you need to draw a straight line. Now that one is for the first equation there. So here, when you let x2 to be equals to 0, then x1 equals to 3. So our coordinate here is 3 and 0. If you let x1 to be equals to 0, then x2 will be equals to what? -1. So we have 0 and -1. Okay, 0 and -1. So we have the points there. So then you do what? You now plot. So you now go and plot. So you now plot. So in this case, we have 1, 2, 3, 4, -1, -2, -3, 1, 2, 3, -1, -2. So the first one is 1/2 and 0. So 1/2 and 0. So 1/2 is somewhere here and 0 is there. So we can name this one as x1 and this one as x2. And then 0 and 1/4. So 0 and 1/4. So it can be somewhere there, a quarter. So and then you do what? You plot a straight line there. You plot a straight line. The next one is 3 and 0. 3 and 0. So it is there. And then 0 and -1. 0 and -1. So it is there. So you plot a straight line. So you plot straight line there. So where they meet here is our solution of what? Of the system. So the solution is here. So that is the solution. And that solution should actually be 3/2 and what? So our solution should be 3/2 and -1/2. 3/2 and -1/2. Okay, so that is how to get the solution by graphing. So we've used 2 methods. We've used the graphing method and the elimination method. So those are things you should know. Any question up to there? Okay, now let's come now to section number 2, which is the matrices. The matrices. So let's start from the definition 2.1, which is the definition. So a matrix is a 2-way array of numbers placed inside a pair of square brackets. So a matrix is a 2-way array of numbers placed inside a pair of square brackets. Okay, if there are m rows and n columns in a matrix, then this matrix is also called an m by n matrix. An m by n matrix. So if we have m rows and n columns, so it is called an n by n matrix, n by n matrix. And this one is of the form, so we put it in a square brackets. So we put it in a square brackets like that. And then we now name A11, A12, and then you go all the way to A1N, A21, A22, and then you go all the way to A2N. Go all the way down here, AM1, AM2, and then you go all the way to AMN, AMN. So that is our M by N matrix. So that is our M by N matrix. So you put it in a square bracket and then you form a matrix of that form. So where the given numbers A, I, J, where I equals to 1, 2, all the way to M, and J equals to 1, 2, all the way to N, are called the entries. So those are called the entries. So those are called the entries. So this is I and this one is J. So this is I and this is J. So this is the ith column. This is the ith row. So I is for the row, and then J is for the column. So I is for the row, and then J is for the column. So it is M by what? By N matrix. So M by N matrix. Any question up to that? Okay. So let's write another definition here, which is 2.2, and this is coefficient matrix. Coefficient matrix. So what is a coefficient matrix? So the coefficient matrix of a linear system with m equations, in n entries, or in n variables, is the m by n matrix in which the I and J entry is the coefficient of the jth variable in the ith equation. Okay. So we actually get our coefficient matrix from these m equations. So these are actually m equations here. So the coefficient matrix, we get them from the coefficients of these equations here. So A11, A12, A1n. So those are the coefficients. It forms the coefficient matrix, So in this case, since this one is an m by n matrix, so it forms an m by n coefficient matrix. Now, what about the augmented matrix? So 2.3, the augmented matrix. So the augmented matrix. So what is this? So the augmented matrix of a linear system with m equations in n variables is the m by n plus 1, m by n plus 1 matrix in which the first n columns are the columns in the coefficient matrix of the linear system, and the ith entry in the last column is the constant term in the ith equation. So here, this is forming the coefficient matrix. Now, when you come and add another column here, which is, and this one is a constant term, then it forms the augmented matrix. So when you bring this one and add it here, since this one is an m by n, then when you bring another column here, then you add here, then it will be m by n plus 1 matrix. Okay, so that is the augmented matrix. That's the augmented matrix. Okay, example number 3. Example number 3. So write down or write out the coefficient matrix and the augmented matrix of the following linear system. So x2 plus x3 equals 0, x1 minus 3x2 equals to 0, x1 plus x2 plus 5x3 equals to 2. So what is our coefficient matrix? What is our coefficient matrix? So our coefficient matrix, and then our augmented matrix solution. So our coefficient matrix, we get it from the coefficients of this one. So our first entry here would be what? 0, right? The next one there is what? 1, and then here is 1. The next one here is 1, right? The next one there is what? -3. And then the last one there is 0. The next one here is what? -1, and then 1, and then 5. So that is our coefficient matrix. So again, make sure you remember the signs. So these signs are also part of the coefficient. So make sure you remember the signs. Now our augmented matrix is now where we add the constant terms. So it is 0, 1, 1, and then the last one there is 0, 1, -3, 0, and then 0, and then finally -1, 1, 5, and then 2. So that is our augmented matrix. Any question? So that is all. matrix. Okay. Now, if you given the matrix and then you're told to write the linear system. So if you're given the matrix and then you're told to write the linear system, like for example number 4, which I'll just, you'll just go do it at home. So write out the linear system of which the augmented matrix is the following matrix. So if you're given the augmented matrix and then you're told to write the solution, the linear system. So it's easy, right? So this is the coefficient matrix, and the coefficient matrix should always be 2 by 2, so 2 by 3 by 3, like that. In this case, it's a what? 1, 2, 3, 1, 2, 3, 4. It's a 4 by 4. So when you remove these, then it becomes now 4 by 5. So this is the coefficient matrix, and then now when you add the last row there, it becomes the augmented matrix. So to write the linear system there, so it is actually easy. It is easy. Now, so now let's come to another section here, section number 3, and this is elimination method and row reduction. The elimination method and the row reduction method. Okay, so we'll use the same example. We'll use the same example. So we'll actually start by example number 5. So find all solutions of the following linear system by applying the elimination method and row reduction method, respectively. So if we have an example, the same example, so let's start from the first one. Use the elimination method. And we did for system of 2 linear equations and the system of 3 linear equations. So how can we use the elimination method there? So let's see the solution. Okay, so what is our first step there? So what we can do is we can interchange equation number 2 and equation number 1. So you can switch. So the first step is interchange equation. So we can name this one as equation number 1, equation number 2, and this as equation number 3. Interchange equation number 1 and equation number 2. Change equation number 1 and equation number 2. So when we interchange 1 and 2, so we get x1 minus 3x2 equals to 5, and then x2 plus x3 equals to 0, and then x minus x1 plus x2 plus 5x3 equals to 2. Now, the next one is next step is we can also name this one as equation number 1, equation number 2, and equation number 3. The next here is step number 2 is add equation number 1 and equation number 3. Add equation number 1 and equation number 3. So when we add 1 and 3, then what do you get? So what do you get? So here, what we can do here is, wait a minute. Step number 2 is replace equation number 3 by equation number 1. Okay, wait a minute. Replace equation number 3 by equation number 3 plus equation number 1. Replace equation number 3. Replace equation number 3 here by equation number 3 plus equation number 1. Equation 3 plus equation number 1. So equation number 3 plus equation number 1. So this and that. So we add. So we retain the first one, which is x1 minus 3x2 equals to 5. X2 plus x3 equals to 0. And then we now replace the last one by adding. So this and this will give us 0, right? And then x2 minus x minus 3. So it will give us minus 2x2, right? And then 5 plus that one is plus 5x3 equals to 2 plus 5 is what? 7. 5 is 7. Then step number 3, replace equation number 3 by equation number 3 plus twice equation number 2 plus twice equation number 2. Replace equation number 3 plus twice equation number 2. Okay. So here you retain x1 minus 3x2 equals to 5. X2 plus x3 equals to 0. And then you replace now. So we can name this one as equation number 1, number 2, and this one is equation number 3. Okay. So replace the last one by now this one, and then you will multiply equation number 2 by what? By 2. So it will now be minus 2x2 plus x2 will give us 0. 5x3 plus the 2x3 will give us what? 7x3. And then 7 plus 0 is equals to 7. Equals to 7. Oh, you don't see that. Equals to 7. Okay, then multiply. So this is step number 4. Multiply equation number 3 by 1 all over 7. multiply equation number 3 by 1 all over 7. Multiply equation number 3 by 1 all over 7. So what do you get? So we still retain x1 minus 3x2 equals to 5. X2 plus x3 equals to 0. And then finally, x3 is equals to 1. Is equals to 1. X3 is equals to 1. Okay, so let's name this one as 1, 2, and this one as 3. 1, 2, and 3. So we have x1 minus 3x2 equals to 5. X2 plus x3
down.
x2 plus x3 equals to 0, and then x3 equals to 1. X3 equals to 1. Okay. Now the next step is we want to eliminate x3 here. We want to eliminate x3 using this. So what you can do is replace x2 by x2 minus x3. Sorry, by equation 2 minus equation 3. Replace x2 by replace equation 2 by equation 2 minus equation 3. So what we get, we retain x1 minus 3x2 equals to 5. And then now we replace this by subtraction. So we take x2 minus x3. So x2, we don't have another x2 here. So x3 minus x3 is 0. So we replace. So we have x2. So the next one is 0. And then 0 minus 1 there is what? Minus 1. And then we have our x3 equals to 1. Our x3 equals to 1. Then finally, we want to eliminate this, our x2 in the first one here. X2 in the first one. So what we can do is replace equation number 1 by replace equation number 1 by equation number 1 plus 3 equation number 2. Equation number 1. Replace equation number 1 by equation number 1 plus 3 equation number 2. So our new equation number 1 will be x1, of course, will remain there. So 3x2 plus minus 3x2 plus 3x2 will give us 0, right? And then the others is 0. And then lastly equals to 5 plus minus 3 is giving us what? 2, right? 2. And then we retain this one, our x2 is equals to -1, and then our x3 equals to 1. X3 equals to 1. So therefore, our solution set is x1 equals to 2, x2 equals to -1, and x3 equals to 1. X3 equals to 1. It's very tedious, right? That's great. So this is by elimination. Now, this kind of step is now taking us to what we call now the row reduction method. The row reduction method. So in this case, then we now write this equation now into the augmented matrix form. Okay, so into the augmented matrix form. So the row reduction method. The row reduction method. So the coefficients here are 0, 1, and then 1, and then 0, 1, -3, 0, and 5, and then -1, 1, 5, and 2. So that is our augmented matrix. So that is our augmented matrix. So now we want to reduce. So what we want to do is we want to make these ones to be ones and these ones to be zeros. And this one here should be 0. Okay. So we want to make the entries below the leading or the main diagonal. So we have to make that to be ones. And then this one should be 0, and also this one should be 0. So how will you do this? So the first step here is you should make sure that the first entry here should be either 1 or it should not actually be 0. So it should not be 0. So the first step is make sure that this one here is not 0. So what you do is you can say R1. So we can use R as a rows. R as a rows. So R1 as row 1. So we interchange R1 and R2. We interchange R1 and R2. So what we get here is 1, -3, 0, and 5, 0, 1, 1, and 0, then -1, 1, 5, and 2. So we have interchanged. Now, since we want to make these ones, this to be 0, so actually it should be like this. So we want to make this one, and this to be 0. So the next step is, since we have already 0 here, then we come to this one. So the new R3, so the new R3 will be, see, R3 should also be R3 here, okay? So if you want to get the new R3, then it should be R3 here. So this and this should be the same. Get my point? So this and this should be the same. So to get a new R3, then it is R3, okay? So that this one can be 0, what do you do to R1? So you add R1, okay? So remember, R3 and this one should be the same. So R3 plus R1. So what do you get? So 1, -3, 0, and 5, 0, 1, 1, 0. And then the new R3 will be R3 plus R1. So this and this will be 0. 1 minus 3 is -2. 5 minus plus 0 is 5. And then 2 plus 5 is 7. Okay. So this and this is already 0. So we want to make this one to be 0. So we want to make this to be 0. So how can we make this one to be 0? So the new R3 there, right, is R3, R3, R3. So it is R3 plus what? 2R2 plus 2R2. So R3 plus 2R2. So what do you get here? So you retain 1, -3, 0, and 5, 0, 1, 1, and 0. and then you have now a new R3 is 0, 2 plus 2 here will be 0, 5 plus 2 here will be 7, and then 7 plus 0 here will still be 7. Okay. That's it. Okay. Any question up to that? Right. The next step is our new R3 here is 1, you multiply R3 by 1 all of a sudden. Okay. So get the new R3 is R3. Yeah. So there we now have 1, -3, 0, and 5, 0, 1, 1, and 0, and then 0, 0, 1, and 1. Right? Okay. Right. So we have this. Now, since we want to make this one and this one to be 0, we already have 0 here. Then we want to make this one and this to be 0. So we want to get the new R2. So to get the new R2 there, then it is R2 minus what? R3. R2 minus R3, which is 1, -3, 0, and 5. The new R2 will be 0, since 1, 0 and 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 1 is -1. Okay? And then 0, 0, 1, and 1. Right? And then finally, we want to make this one to be 0. So to get the new R1, then it is R1, right, plus 3R2, which will now be, the new R1 is 1, R1, which is 1, and this, that is 1, minus 3, no, this is plus. What am I doing? Oh, it's here. Minus 3 and then plus 3, which is 0. 0 and 0 is 0. 5 and -3, which is what? 2. And then this 0, 1, 0, -1, then 0, 0, 1, and 1. That is it. Okay. That's it. So therefore, our solution set will now be our new solution set or new linear system there. Since this one is x1 equals to 2, x2 equals to -1, and x3 equals to what? Equals to 1. Are we together up to that? Okay, up to that. Any question? We'll do more of this, so you'll get used to it. Then you'll get used to it. So our time is up. Right. So we will meet. So I'll pause the homework after the class, and then I'll also pause this in Moodle. Okay. See you tomorrow.
Thank you.
You too.